Okay, so I'm going to start the slideshow. Hello, everyone. My name is Sydney Feldman. I am a medical student and Master's of Public Health student at University of Maryland School of Medicine, and I'll be presenting this information session about COVID-19 vaccination. I would first like to thank Dr. Sharon Tennant and Dr. Teresa Leslie for providing the basis of the information for these slides. So I'll first give an overview of vaccines and vaccination and then go into some specifics about COVID-19 vaccines. So what is a vaccine? A vaccine provides immunity to a specific disease. It typically contains an agent that resembles a disease-causing microorganism, such as a virus. And that agent stimulates the immune system to recognize it as a threat and destroy it. And then the immune system creates antibodies against it that can destroy the associated microorganism in the future. So COVID-19 vaccines all utilize something called a spike protein, or an S protein for short. And coronaviruses have this S protein on their surface. The COVID vaccines stimulate the immune system to create antibodies specifically against that S protein, and the antibodies can then attack the S protein and kill the virus. When someone who's vaccinated is exposed to the virus, that's exactly what happens. The antibodies bind to that S protein and then the virus is neutralized. So I'll talk about the mRNA vaccines first. This is the Pfizer vaccine and the Moderna vaccine. So for a little bit of background as to what mRNA is, the way that things work in our body are a lot of processes are carried out by proteins. Proteins originally come from DNA, which is what makes up our genes. So DNA is turned into mRNA, and mRNA is then turned into protein. So that's how mRNA fits into cellular processes in our body. So the mRNA vaccines are made of mRNA, and they're made specifically of mRNA that codes for the S protein that we just talked about that's on the surface of the coronavirus. So when a person is vaccinated, the body receives this mRNA. It translates the mRNA into the S protein. And the immune system then sees the S protein and creates antibodies against it. And as I explained previously, these antibodies are then available to be able to recognize the S protein on the actual coronavirus should a vaccinated person become infected. Some important things to know about these mRNA vaccines are that mRNA cannot be incorporated into DNA. This is because mRNA stays in a different part of the cell entirely from DNA and they do not come into contact. Also, mRNA only stays in the cell for a short time. Once it's used, it is eliminated. Additionally, the mRNA vaccines do not contain the coronavirus. They only contain mRNA that codes for just the S protein. And lastly, once the S protein is created from the mRNA, it cannot do any harm. This is because it's just the protein by itself. It doesn't have any other parts of the virus that are required to make it actually harmful. I'll now talk about the viral vector vaccines, which is the method that Johnson & Johnson uses. So the way this works is it uses a different virus, which is not the coronavirus, as a carrier for a gene that instructs the cells to create the S protein. So the rest of the process is pretty similar to the mRNA vaccines. And the immune system will see the S protein once it's created and then make antibodies against it. And these antibodies are available to recognize the S protein on the coronavirus should someone who's vaccinated with Johnson & Johnson become infected. An important thing to note here is that the viruses that are used as vectors are harmless. So they're chosen because they're either a virus that does not cause disease in humans in the first place, so maybe something that only causes disease in a certain animal, or it's a virus that has been modified so that it cannot cause disease to humans. This is a little bit of an illustration of the concept of herd immunity, and it helps to show how the vaccines can protect us, especially when a lot of people in the community are immunized. So the first panel shows how viral transmission works when there was no vaccine. So the person in the middle has COVID, and then they are able to infect a lot of people around them. Now, in the middle panel, with a vaccine, the person in the middle has COVID, but everyone around them is vaccinated, so they're protected against getting the virus, and then they can't get sick, and they also cannot spread the illness to anyone else. This does come with a little bit of a caveat now, because vaccines are, while they're highly effective, they're not 100% perfect. And we also have the Delta variant, which is extremely contagious and infectious. So with vaccines, now that we have the Delta variant, they're still very effective at preventing severe disease, and they're still very effective at stopping the transmission of COVID. However, there is some evidence that the disease can spread to people who are vaccinated, and that people who are vaccinated could spread COVID to other people. However, the vaccine is still very important because we know that people who are vaccinated, even if they do get COVID, they are most likely going to have mild symptoms or no symptoms at all. So the more people who are immunized, the more people will only have mild symptoms, even if they contract the virus. And another important thing to remember is that breakthrough infections, which is the term for infections of people who are vaccinated, are still extremely rare. Next, I'll go through some common concerns that you may have about vaccines. So one of the common concerns with the COVID-19 vaccines is that they were made very quickly. This is some background information to help illustrate the process of creating any new medical invention, whether it be a medication or a vaccine in this case. So there's a number of different phases. Phase 1 is primarily looking at safety. Phase 2 is used to establish proper dosing. Phase 3 is for efficacy, which means, does this vaccine actually work the way it's intended to? And then phase 4 is additional monitoring for safety after a vaccine is already out on the market and released for people to use. And you'll see throughout the chart that safety is assessed actually at every single phase as well. Typically, a vaccine does take about a decade to be developed. This is in part because usually all of the phases happen in a certain sequence as shown on this timeline, and it's also extremely expensive to be able to carry out these kinds of trials. There are a number of reasons that the COVID vaccines were able to be produced so quickly. One is that governments around the world contributed significant money to companies to develop the vaccines. So this helped fund the research, but also allowed vaccines to be manufactured at the same time that the trials were being performed. So that was another way to save time, because typically the manufacture takes place after the trials are performed. But in this case, as soon as the emergency use authorization was granted by the FDA, the vaccines could go out into communities because they had already been manufactured. Another thing to keep in mind is that although these mRNA vaccines are new, the research underlying the use of mRNA as a vaccine method has taken place for about 15 years now. And then lastly, a lot of people were working on this. So many projects in medicine and science as a whole kind of came to a halt when the pandemic started, and everyone's attention was focused on things to help with the pandemic. So one of those was creating the vaccines. So there were just a lot of people working on this all at one time. Another concern that I have heard is that the vaccines have side effects. So the most important thing to remember is that most side effects are mild. These are usually pain at the injection site, a low fever, headache, fatigue, muscle pain. Severe allergic reactions are rare, but I will talk about two of them. So one is called thrombosis with thrombocytopenia syndrome, which is basically a fancy name for blood clots. This has been seen after the J&J vaccine, but it's extremely rare. So the rate of this happening is 7 cases out of 1 million people vaccinated. And this rate is actually specifically in 18 to 49-year-old women. So it's even more rare in other groups. And just for some perspective, in contrast, car accidents cause 124 deaths per 1 million people. So that is much more likely than having this specific severe reaction. The other severe reaction that I'll touch on is myocarditis and pericarditis. So that's inflammation of the heart. And this is seen after the second dose of one of the mRNA vaccines. But again, it's extremely rare. The rate of this is 12.6 cases per 1 million people vaccinated. Another common concern is that the vaccines do not have full approval. So the vaccines were given approval under an emergency use authorization, and this authorization is a mechanism to facilitate the use of medications and vaccines during public health emergencies. So full approval beyond an emergency use authorization requires additional monitoring, so it is just not available right away. And we know now that the Pfizer vaccine has been granted full approval, and the Moderna and J&J vaccines are under review for full approval. And this is just because the Pfizer company submitted their paperwork for the approval earlier than Moderna and J&J, so it's just taking some time to review the applications and the data for those other two companies. Another concern that some may have is that mRNA can change DNA. So I touched on this a little bit earlier in the presentation, but just to go over it again, mRNA and DNA exist in different parts of the cell. So this is a diagram of a cell, and there's the circle within the cell that's shaded a little bit gray. This is called the nucleus, and this is where DNA resides. And then the area outside of the nucleus in the larger circle is called the cytoplasm. And that's where mRNA exists when it enters the cell, and it stays there, and it does not enter the nucleus or come into contact with DNA. And a couple of last concerns may be that not enough people have taken the vaccine, but actually at this point, which is as of November 7th, 2021, over 193 million people have been fully vaccinated in the US alone. And you may also have the concern that the vaccines can cause fertility issues, but there is currently no evidence that any vaccines, including COVID-19 vaccines, cause fertility problems. And in fact, many people have become pregnant after receiving a COVID-19 vaccine, including some who got vaccinated during COVID-19 vaccine trials. And the final thing I'll touch on is the concern that public health messaging seems to change very often. And this is really just the nature of science and the nature of discoveries in medicine. So there are many groups working around the world on COVID-19. There's a lot of data being generated. And as more and more data are produced, the understanding of COVID-19 improves and it evolves. And as the understanding changes, sometimes public health officials have to change their recommendations. And excitingly, over 163,000 research papers have been published about COVID-19. So there is quite a lot of information being learned every day. And finally, I'll go over some of the most recent updates. So first, I'll talk about booster vaccinations. So who is recommended to get a booster? If you received Pfizer or Moderna, I'll talk about that first. So if you received either of those brands of vaccines as your initial series and you are 65 years or older, then you're recommended for a booster. The other group that's recommended is if you're 18 years or older and any one of the following applies to you. So if you live in a long-term care setting, if you have underlying medical conditions, or if you work or live in high-risk settings, and you should get your booster 6 months after you received your second shot. So looking into some of the details, there are a number of underlying conditions that would qualify you for this recommendation. So this includes cancer, chronic kidney, liver, lung, or heart disease, dementia or other neurological conditions, diabetes, Down syndrome, heart conditions, and an immunocompromised state, as well as mental health conditions. Some more are overweight and obesity, pregnancy, sickle cell disease or thalassemia, former or current cigarette smoking, a history of transplant, a history of stroke, substance use disorder, and tuberculosis. And these conditions are all thought to increase your risk of serious illness from COVID. And I do just want to mention that vaccines are very much still effective against COVID, including against the Delta variant, but the effectiveness can decrease over time. So because of this, these certain groups are recommended to get a booster. And then I'll also touch on the high-risk settings that are mentioned in the recommendations. So this is if you live or work in any of these settings. So these are first responders. Some examples of those will be healthcare workers, firefighters, police, and congregate care staff, but it's not limited to just that list. This also includes education staff, food and agriculture workers, manufacturing workers, corrections workers, U.S. Postal Service workers, public transit workers, and grocery store workers. And for Johnson & Johnson, everyone who is 18 years or older is recommended to get a booster. There are not any additional qualifications like there are for Pfizer and Moderna. And the timeline is a little bit different for these as well. It is recommended 2 months after you received your original shot. And you also have the opportunity to mix and match for your booster. So you can choose any of the 3 approved vaccines. It does not have to match what your original vaccine was, though it can match if you want. And as of this month, the CDC has not released recommendations as to which specific booster to choose. So it's really up to you, and any of the 3 that you can choose will increase your immunity. The other big recent update has been vaccinations for children aged 5 to 11. So the CDC is now recommending vaccination for this age group. This is with the Pfizer vaccine only. Just some details are it's 1/3 of the dose given to adolescents and adults, and it uses a smaller needle. So trials have been conducted in research volunteers in this age group, and the data show that the vaccine is safe and that it is almost 91% effective at preventing infection in this age group. Like everyone else, these children will receive a second dose 3 weeks after the first Pfizer dose, and this is currently under emergency use authorization from the FDA. Some more announcements that could be on the horizon are perhaps booster guidelines for those not currently in the recommended groups for Pfizer and Moderna. We may hear about other vaccine options, such as the Moderna vaccine for those under 18, and perhaps specific mix and match recommendations from the CDC. But these are all just potential ideas. I'm sure we will see how the scientific knowledge continues to evolve. Thank you so much for listening.